Hello there, we have a new feature in our game Empty Space that's gonna be out in a couple of months for PC right now. It's available for free for mobile devices. You can just go ahead and download it for free for mobile. For PC though, the story is a little different. I mean, everything's pretty much different. It's a completely different game, but it's continuing the exact same story from another perspective. Right now we have a new feature. It's about interactive grass for the game. So let me show you the new feature that we have right now. I have to go into this map. I've already set up a debug for myself. Let me fix the sound problem as always. Okay, let me find the grass. This is the character. So when we go into the grass bends away. I don't know if you can see it. Yeah, it's pretty obvious this way. The grass bends away, and when we get out of the distance, when the distance is more than enough, the grass can just get straight as always, like a normal grass. But when you're pushing forward, they're bent, like the way they should too. So this is a new feature, and everything's pretty interactive in this game. You can just destroy, you can bend things. As you can see, the grass bends away, and when you come back, it gets straight. It's a pretty neat feature. It adds another layer of realism to the game. So this is a feature from this part forward. We have the tutorial for the people that want to know how this is done. Okay, so the way I've set it up, I've used a material collection. So right click, material parameter collection, and for me it's called ripples because I'm using it for my ripples as well. I'm using the player position for this one. So it's a vector parameter, it's got RGB and A. I've named it player position, and then whenever the character is moving in, I'm using the third person character template. I've changed it a lot. It's got the basic setup, so I don't really have to do the basics. And whenever the movement input is triggered, I am setting up the player position, and that's it. Set vector parameter value. As you can see, right click, set vector parameter value, this one here under material, this function right here. And then for the collection, we're setting the material collection we've just created, this one. And for the RGB values, it's X, Y, and Z. We're not going to be working with the A value, it's the alpha. We just want a 3 vector, not a 4 vector, so we just get the actor location, get actor location, and then right click on this one, split it, and then X to R, Y to G, Z to B. And that's it. We don't need to do anything else, because every time the character is moving, the position should be updated. It doesn't have to. You can go ahead and do it inside the event tick, but I don't think that kind of makes sense. The way it makes sense though is to do it by the way I showed you, by the input trigger. And then we have to go into the material section of our foliage. I've already found it, but if you can't find it, you have to find the mesh and then go into the material. If it's an instance, then just open up the parent material, and then you'll have the parent material. I'm not going over into how to create a foliage material. That's like a really complex topic. I'm only gonna be talking about how to make them bend away from the character. And this is the whole code. I mean, if you know what you're doing, this is the code, and this one goes into the world position offset. If you have something else like a grass wind or something like that, you'll just add this to the other WPO you have, and then it goes into the world position offsets. Okay, let's explain them in detail. So we're getting the world position, so type in world position, this one right here, and it should be absolute world position, the first one right here. And then we'll get the player position. For that, just drag in the material collection you created and then select the player position that we just created. And then we have to mask it out. Just use a component mask. We need RGB. As I told you, we need the X, Y, and Z. And then we'll do a subtract from world position by player position and subtract this one right here under the math. And then we'll normalize it like so. And this one's the direction. I've commented on them so you can just understand a little bit better. This is the direction of the band, so it needs to be against the character. And then another one called length right here under utility is the distance. And then we'll divide it by a scalar parameter. Just type in divide. Scale parameter, just hold S, or if you want to just put a value, hold 1 on your keyboard and then put a value. For me, 100 works pretty well. I didn't change this one. You can though. Maybe you have some foliage that are a little bit smaller, maybe some are a little bit bigger. For those, you have to use a scalar parameter with different material instances, so keep that in mind. And then 1 minus is what we need here, and then a saturate is gonna be the fall off. Saturate, and then this is the fall off for us. And then hold M on your keyboard, and you'll have a multiply. So multiply fall off by band strength, or band strength, I mean scale parameter. Hold S on your keyboard, left click, and then type band strength or something, whatever you need, or just type in a value of 500 works best for me. This one goes into this, and then this one gets multiplied by the direction. And then another multiply we have here, and here from the world position you have to subtract it from the object position. This is because we don't want the whole foliage to be bent over. We want, for example, if the whole Z value is 100 centimeters, we need the first 50 centimeters to be still, and then the second 50 centimeter to be bent over or bent away from the character, because we don't really need them to be, if this is the ground, we don't need them to be like this. We only need them to be bent over like this, so they have to be stuck in the ground. And for that we have to subtract the world position by object position absolute. Yeah, because I already have it. Okay, and this needs to be absolute world position, not the relative. And we only need the Z value, so component mask, and then only need the B or Z, doesn't matter. So X, Y, Z, RGB, we don't need the RG, we only need the B. And then divide it by the height. For me it's 150. If you're using it on different foliage, you have to you'll need a scalar parameter. For me, I don't really need a scalar parameter, but I've already created one, so 150 is fine for me. And then saturate, and then multiply by whatever we have coming out of the direction. And this one goes directly into the world position offset. or again, if you have another WPO, which for me, I have a simple grass, which shouldn't be like the best way to do it, but anyway, I've added it with the grass wind, so this is going to be my world position offsets, and this is what we have, and it looks gorgeous. I have another, not this one. I have another map which is a jungle, and you can see them in motion. They look really good. They change the whole feeling of everything a lot. So they all react to the character, and that looks really good. That makes everything so smooth. And this was it. It's a new feature in my game. It's a very old method in game development, but I've used something really cheap, so I don't think that this is going to be, it's not, the performance is gonna be really good. This is 263, which is really low for a PC game. You can even use it in a mobile game. It's that cheap and performant. And I wish you a great day. Bye.